So let's dive in a little bit more on the electrons and the overall charge of an atom. So we already discussed, and we know that charge comes from comparing protons, which has a plus charge, to the electrons, which has a negative charge. And in the atom, those two particles, those two subatomic particles, are going to cancel each other out in terms of overall charge. So if the number of protons is equal to the number of electrons, let's use sodium again. If we had in a sodium atom, it had 11 protons. All right, well, what that means is that atom of sodium has 11 plus charges housed in the nucleus. So the nucleus is a positively charged part of the atom. So we have a bunch of plus 11s in the nucleus. All right, there they are. So the nucleus is positively charged. Well, on the outside of the atom, you have all of these negatively charged particles moving around on the outside. If there are 11, so here's our little cloud. Don't make fun of my drawing. You guys know I'm not the greatest at it. If I have an atom that has 11 electrons, that means there's 11 of these negatively charged particles, and I could draw 11 on here. I'm not gonna, I guess I should. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, I have all these negatively particles, these negatively charged particles floating around on the outside. Well, that equals negative 11. So if I had, in math class, I had a plus 11 that I added to a minus 11, what happens? It cancels out. We have 0. Well, the same thing happens with the charge. So this particular sodium atom with 11 electrons and 11 protons, they cancel each other out. So the overall charge on this atom is 0. Okay? We're going to assume that all of the elements that you take straight off the periodic table are neutral charge, so that they have this type of relationship. Their nucleus is the same number as the particles in the electron cloud, so that they cancel each other out. So what happens if these numbers are not equal? What happens if we have more protons or more electrons? Well, we get this type of relationship. So if the number of protons is greater than the number of electrons, you're going to have a positively charged atom. We call positively charged atoms cations. These are most commonly found in metals on the periodic table. Okay? If we have a situation where we have more electrons than protons, so protons are less than the number of electrons, this is going to form a negatively charged atom, and it's not called a cation. This is a misprint here. All right, this is going to be called an anion. Okay, and these are most commonly found in your non-metals on the periodic table. Okay, now these kinds of situations happen when we place elements in compounds. Okay, when we chemically react them and bond them to other atoms, we get these types of situations. We form anions and cations. We mess with their electron number. This is what is a chemical reaction. So ions, which are charged particles, so whenever we have a charged overall particle, whether it's a positive, whether it's a negative, they're formed ions, and we can call them cations if they're positive, anions if they're negative. This happens from chemical reactions. Atoms that are negatively charged, they've actually gained electrons, all right, because they have more electrons than what's housed in the positively charged nucleus. If you have a positive charged ion, you've actually lost electrons. You have less electrons floating around than the positive charge in the nucleus, okay? So one thing I want you to remember here, all elements are neutral and not charged, okay? So if you're talking about an element, they are neutral and have not been charged because we haven't reacted with them, okay? If you have a charged atom, it's called an ion. It's no longer just an element. It has been reacted and is part of a compound. Okay, so ions become because we've chemically reacted them and bonded them to another atom. Okay, so they are found in compounds. So for example, if we go back to sodium, to get sodium into a charged particle, to make sodium become an ion, I'm going to react it with chlorine to make sodium chloride. So what happens here is electrons are transferred. So they go from my metal to my nonmetal. So the electron here that's in the atom of sodium, one of them gets transferred over to an atom of chlorine. So now what we've done is we've chemically reacted these two elements to form ions. So because sodium is sodium, so it has 11 protons, and its neutral atom here had 11 electrons. Well, because we chemically reacted it and we forced it to give up its electron to bond with chlorine, it now has one less electron. So we've got the 11 protons. Our electrons are now 10. So what happened to the overall charge? Well, 11 plus charges and only 10 minus charges gives this gives this sodium now a +1, right? It has one less electron than protons. All right, and then our chlorine, what happened to that? Well, chlorine, in its neutral elemental form, has 17 protons and 17 electrons. Well, what we did here when we bonded it with sodium, it took in an electron, so it gained an electron. So what happens? Well, it went from having 17 electrons to now it has 18. So what happened to that charge? Well, because there's only 17 plus charges and now there's 18 negative charges, chlorine is now negatively charged. So it's got that -1. We would call this a cation because it has a positive, and this would be called an anion because it now has a negative charge. So when we're dealing with elements, they're neutral. When we're dealing with ions, we have bonded them to another atom and we have rearranged their electrons.